Okay, good morning everybody. It is Tuesday morning. It is the 27th, 10/27. So today, what we want to talk about specifically is rational exponents and negative exponents. And we're going to add a couple other things in there, which you probably already know. So let's take a look. Example 1, 2, and 3 are kind of reviews of what we learned last year, but I'm going to go through it real quickly. So when we see a fraction with square roots, you can change this to really like the square root of 9 over the square root of 16. So instead of looking at it as a fraction, look at it as two different square roots, okay? If I do that, then it gets pretty easy. Instead of the square root of 9, we know that's just 3. And instead of the square root of 16, we know that's 4. So that one's a pretty simple problem, okay? Now, when you go to example 2, here's our problem with example 2. Hold on. I got to grab a red pen. Got it. So here's our dilemma with example 2. You've got a whole number and a square root. So there is a rule that you can't have a square root in the bottom, okay? Can't have a root in denominator. And you're going to use that rule in calculus, which I'm getting you ready for calculus someday, okay? So if you can't have a rule in the denominator, we learned that if you can fix the problem with the problem, fix the problem with the problem. Well, the problem is here. The problem is the square root of the denominator. So we fix a problem with the problem. So what I'm going to do is multiply by the square root of 5. But I got to do both top and bottom. Square root of 5, square root of 5. Okay? So I'll say it again. We see a square root in the bottom in the denominator that we can't get rid of. The way we get rid of it is to fix the problem with the problem. The problem was square root of 5, so I multiply top and bottom by the square root of 5 or square root of 5. You have to do top and bottom the same because in a sense we're multiplying by 1. That is the number 1, which does not change the value of the problem. So if I do that, let's see what I get. I'm going to get a 3 square roots of 5 over the square root of 25, right? 5 times 5. And then I'm going to get a 3 square roots of 5 over 5. Don't divide those because, check it out, that is not 5. That is not, in fact, if you look at this real quick, square root of 5, that is not a 5. That's a 2.23. Don't divide this. That is a 5, but that is not a 5. It's a square root of 5, which is a really ugly number. So there's your answer. However, we got rid of the square root in the denominator. So there's no longer a square root in the denominator. That's why we do this problem. Okay, now let's look at example 3. So example 3, we learned over here that you can rewrite this as two different square roots. Square root of 5, square root of 7, right? Well, we still have a square root in the bottom. So let me go ahead and rewrite that. Square root of 5, square root of 7, right? And what we want to do is get rid of the square root in the bottom. So my trick was to fix the problem with the problem. So I'm going to multiply top and bottom by the square root of 7 over the square root of 7 because it's the square root of 7 and the denominator that we can't have. Alright, in the numerator we can multiply these. We can get a square root of 35 and a square root in the numerator or the top is okay. However, down here in the bottom you're going to have to get rid of it. Square root of 7 times square root of 7 is square root of 49. But square root of 49 is a perfect square. So the square root of 49 is 7. Don't divide those. That is not a 35. It is not a 35. It's an ugly square root. Square root of 35. Don't divide those. Square root of 35 is not. That is an ugly number. That is 5.91 blah, 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 blah. So leave it like that. But what we have now is we have a term without a square root in the denominator. Okay, now to do example 4. So before we do example 4, I'm going to write some special numbers up. Above, I'm going to write these numbers. Okay, so I'm going to write 8, 27, 64, 125, 216, 343. Okay, these are perfect cubes. These are perfect cubes because the cube root of 8 is 2. 2 times 2 times 2. 3. 3 times 3 times 3. 4. 4 times 4 times 4, 5. 5 times 5 times 5, 6. 6 times 7, and then it keeps going. But these are all going to need. So if we take a look at example 4, what I need to do is rationalize the denominator. So I need to make this denominator one of these numbers so I can take the cube root of it. I need to make this bottom number one of these numbers. So I'm going to multiply it by 2. I'm going to multiply it by the cube root of 2 so I can make an 8. So I'm going to multiply top and bottom by the cube root of 2 over the cube root of 2. The reason I'm going to do that is because then when I multiply, I'm on the denominator going to get a cube root of 8, okay, which is going to be 2. All right, so I'm going to multiply here. I'm going to get a cube root of 4, which is an ugly number. I get the cube root of 4 over, well, the cube root of 8 is 2. It is 2, because 2 times 2 times 2 is 2. Don't divide those. That is not a 4. That is not a 4. That's an ugly number. That's the cube root of 4 is some 1.57 blah, 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 blah. So just that's your answer. Okay, example 5. So we have learned in geometry and in algebra that if you have a fraction, if you've got an exponent to an exponent, let's just multiply exponents. So I get a 3 to the 2 fourths. 2 times 1/4 is 2 fourths, or 3 to the 1/2, which is okay, or we can rewrite that as the square root of 3. Okay. Example 10. We've learned that if you've got two bases that are the same, you can subtract exponents. So if I take 10 to the 1/5, subtract 1. Okay. Subtracting exponents, I get 10 to the negative 4/5. Okay. And I'm going to leave that answer as that. 7, same thing. I'm going to multiply exponents. I'm going to get a 3 to the negative 4/4, which is 3 to the negative 1, which is 1/3. Okay. Example 8. Well, I'm going to do this first. Oh, my phone's so annoying, especially when I'm recording. I'm going to add exponents. When I multiply the same bases, I add exponents. So let's add. When I get a 2 to, let's see, negative 3/4 and positive 1/4 makes a negative 2/4 if I add exponents to the negative 1 power. And then I'm going to multiply exponents. Negative 2/4 times negative 1 is a positive 2/4. So I get 2 to the positive 2/4. Same thing as 2 to the 1/2 or square root of 2. Either one of those answers. Okay? All right. Turn the page. We're getting there. Okay. All right. Let's see. Cube root of 81. Well, that's the same thing as, let's see, that could be a cube root of 27 times a cube root of 3. That's my 81. Why did I want to write it like that? I'm not done. I'm not done. Why do I want to write it like that? Well, because 27 is a perfect cube root. Now, the cube root of 9, well, I don't know anything about the cube root of 9, so I'll just put the cube root of 9, okay? Let's see then. I know the cube root of 27 is 3. 3 times 3 times 3, right? Oh, check this out. Then cube root of 3 times cube root of 9 is the cube root of 27, right? And then I know the cube root of 27 is 3, so I get 3 times 3. The whole answer is 9. Sweet. Okay, example 10. Let's take a look at example 10. Well, what am I going to do? Well, I'm going to go ahead and do this, because like 2 can't go into 50. Now they're both cube roots, so let's see. I'm going to rewrite this as cube root of 5. This will divide and make it a cube root of 25. Let's see. I think if I multiply those two, I'll get 125, right? That's a perfect cube root. So if I multiply these two, I'm going to get the cube root of 125, and that is 5. 5 times 5 does 5. All right, let's take a look at example 11. Example 11 looks hard, but I think I can do it. Let's see, that's going to be the 4th root of 48 over the 8th root of 9. How's that going to help me? Well, let's see. I can probably make this into, let's put it as fractions. I've got 48 to the 1/4 over 9 to the 1/8, right? I think if I change this into a 1/4, let's see, 48 to the 1/4 over 3, let's see, 3 squared is 9, and then with the 1/8 makes 3 to the 1/4. Okay, I'm getting somewhere, because then I can go 48 to the 1/4 minus 3 to the 1/4. Let's see, I've got the same bases. I can probably divide these. I think I can divide these. That's like the 4th root of 48 over the 4th root of 3, which I think is the 4th root of 16. Oh, wait a minute, that's 2. That is, because 2 times 2 times 2 times 2, what do you know? There you have it. Okay, that's what I have for today. I have a short journal work for you, and I'll put that up.